All right, so I just want to recap really quickly what we're going to see in the free response. You'll see a capacitor circuit. That'll be 2 or 3 questions. You'll see a combination circuit with resistors. That'll be 2 or 3 questions. And then you'll see a multi-loop. And that'll be 3 questions. Just what are the 3 currents in this multi-loop circuit? And then in the multiple choice, you're going to see, let's see, we're going to see caps in series and parallel. There are 20 multiple choice, by the way, caps in series and parallel. We're not going to see like the area and the distance between the plates. That was all the previous exam. So just capacitor circuits. And then we'll see current, Ohm's law. This is all chapter 3 stuff. Power, voltmeters and ammeters. Basically 1 or 2 questions, about 1 question for each of these topics for these in chapter 3. And then in chapter 4, we had series resistors, parallel resistors. You had combination circuits. So you'll have like 1 or 2 questions. We have 1 question for parallel, and then I think 2 questions for resistors in series. And then you'll have 3 or 4 combination circuits. That'll be both calculations and qualitative. So like one of those, what happens to the voltage here if this happens, or which has the biggest current, or which has the biggest voltage, that sort of thing. And then finally, you'll have multi-loop. As you're studying through the old test, just be careful, because some of these last things are in exam 3 for some exams. As you go back, you'll see when you see the multi-loop. And if you get to things like RC circuits, where you have a resistor and a capacitor together, not doing that. Or if you get anything about household circuits, we're not doing that. So none of that. That includes things like GFCI, circuit breakers, grounding, anything about the home. You're not going to see that. Although some of it might look somewhat familiar to you, because we've already talked about some of those topics. So none of those things are going to be on the test. Luis?
Will those be on test 3?
Yeah, of course. Yeah, we'll pick right up after the exam on Wednesday. Household circuits is really kind of interesting, I think. And it's a good application of what we're doing. So yes. You mean on our exam 3?
Yes, sir.
Yes, absolutely. We won't skip anything. We'll probably have a day or so at the end that's free, in fact, where we just finish everything beforehand. Okay? Particular questions that y'all have are topics, maybe just particular topics that you want to look at. Yeah, Tam.
Like, whenever you would say like resistors in parallel, like that increases the voltage, like can you go through that? You kind of mentioned it at the end of class.
Yeah. So when I have resistors in parallel, can I turn this light out, the one up front? Sorry, wasn't ready much. I'm going to turn the light out up front. So when I have resistors in parallel, or really in combination circuits, I think that's what you're asking, where if I have, say, a circuit like this, I have a resistor, and then I have 2 or more resistors in parallel. And then what happens, say, if I take away a resistor? What happens to the current or voltage in the other resistors? So this is not intuitive, but if I add a resistor in parallel, the equivalent resistance decreases, because you're adding an additional path for the electricity to flow. Even if it's a huge resistor, you're still lowering the resistance. And then if I remove resistors in parallel, if I have a resistor that's in parallel and I take it away, then my equivalent resistance will go up. And that's not intuitive, because you think, oh, if I remove a resistor, my resistance must go down. But it's the opposite, okay? Because if I remove a resistor in parallel, that means I'm removing an additional path. So it makes it more difficult for the electricity to flow. So for example, if I take away this resistor, that means that the equivalent resistance of this whole thing right here is going to increase. And if the equivalent resistance of that thing increases, that means that the voltage across that whole branch is going to increase too, which means that the voltage over here is going to decrease. And then, there could be any number of questions where I could say, well, what is the power or what is the current? But it's all really about what happens to the voltage. So if the voltage goes down, then of course the current's going to go down or the power is going to go down because those are all directly related. And then likewise over here, if the voltage goes up, then the current's going to go up through that remaining resistor and the power will increase through that remaining resistor as well. I think that's what you're asking. Is that your question?
Yeah, I just think that you have to go like REQ or just R. But go by the REQ.
Yeah, you go by the equivalent resistance. So if the equivalent resistance of a parallel branch goes up, if it's in, okay, let me step back. So there's a separate question that we did in class. So what if I just have a circuit that's just parallel? Let's add a third resistor. That I have a circuit like that that are just parallel resistors. If I say take away one of these resistors, that means that this equivalent resistance is going to go, if I take it away, that means that the equivalent resistance will go up, right? Now the voltage is going to remain the same. The voltage will be whatever is the voltage on the battery. But the current, if the equivalent resistance goes up, that means that the current will go down. Okay? And actually, I'm sorry, I wrote this incorrectly over here. Think like that. It's a little more, I'm just going to take this away. Can I just take that away? Okay, all right, just take that away. Wasn't exactly right to say that. Okay? All right, you will have a question where I say, what happens if you take this resistor away? It's not going to be a terribly complex circuit, like it'll look a 3 resistor circuit, I think, like this. Or if I take away one of those resistors, what happens to something in the other resistors? Look back at the old exams, you'll see examples of that. Good question. They're all good questions because they're all going to be on the exam. Like every topic, there's no topic uncovered on the exam. Yeah, Megan.
So is the current not affected by the other resistor, like in the first part?
Okay, so really, if I take this resistor away, that means that the overall equivalent resistance of the entire circuit is going to go up. And if the overall resistance goes up, that means that this current will decrease. Because if I take away one of those resistors, I'm just left with 2 resistors in series. And we know that resistors in series have the same current. There will be a question, by the way, about those rules, maybe 2. Resistors in series have the same current. And so if whatever current I have here, I'll also have here. And if the equivalent resistance goes up, since V equals IR, if this goes up, that means that this goes down. Does that answer your question? Okay. There are lots of little rules that fit together with circuits. Well, there are 8, 12, 10 little rules that all fit together. But if you get all those rules, they're not complicated. If you get them all and fit them together in your head, that's won't be difficult. Emily? Yeah, so let me repeat what I think you said. If I have resistors in parallel and I change the number of resistors, what changes? The total current changes, yeah. So if I have resistors in parallel and then I add another resistor like this, that means that the total current will increase. You see, each of these little resistors has its own current. And if I add another resistor, it adds that amount of current. And also, they all have the same voltage as the battery. But if I add resistors in series, that's like an EKG or something. But if I add resistors in series, that makes the current go down, not up. Because I'm increasing the equivalent resistance, which decreases the current. Okay? Particular questions on exams or particular topics that you want to look at? Yeah. Let's look at some old exams. You mean like on the free response? That's what you mean. Let's see. I have that still. Let's see if this website. Oh, it's not. Oh, yeah, it is still up. So I'm looking for an old website that I had. Can y'all give me one second? I'm gonna blank this and stop the recording. You know, good practice for you. They're just capacitor circuits, but they're laid out differently. So this is not a complicated circuit. I know it looks complicated, but it's not. So on this circuit, what we want to do, this is what you're asking, right, Carson? Yeah. So on this, what we want to do is to redraw it. And when we redraw it, then we'll begin to understand better what it looks like. I'm always going to start from the positive side of the battery and go away from the positive side. It just sort of, I think it's useful just to have a step that's always the same. And so I'm going to redraw it. There's my 12-volt battery. And now I'm going to draw, notice here that I have a junction that breaks into two pieces. So I'm going to have a two-piece junction right here. On one side, I have the 2 microfarad. On another side, I have the 4 microfarad. And then those two come back together right here. So that ends my parallel junction. And then I have another right here, where I have just a capacitor between those 2 points. And then I come here and I break into another set of 2 junctions, where I have a 4 and a 4 and a 10. And then I go back here. So I have 4, 4, 10. 10 microfarad. And let's see, this was a 4 microfarad. This was 2 and 4. And this was 12 volts. Let me point out here. So what I did here is I started here, and I go along and I look for my first junction. And notice that there are no capacitors between here and the first junction. And then that junction splits into 2 pieces. These 2 pieces come here, and then they come back together at this junction. So that's why I draw this parallel branch like this. It's all by itself, and it's in series with this capacitor. So as I keep going, I draw this 4 microfarad capacitor. Notice there's no other junctions in between, so I just come here. Now, sometimes students get confused because it's 90 degrees. Not a junction, it's just a bend in the wire. So I come along here to the 4 microfarad, which is right here, and then I come along and I split into 2 junctions. They go into these 2 parts. So I have a 4 and a 4 and the 10, and then that comes back over here. So I can simplify this, which is, once you do this part, I think that's the hardest part. But I can simplify this. A 2 and 4 in parallel is 6. This 4 and 4 in series is 2. And so I'm left then with a circuit that looks like this. 12, I have a 6 microfarad, a 4 microfarad, and then 10 plus 2 is 12 microfarads. So this circuit simplifies to 6 microfarad, 4 microfarad, and 12 microfarad. Okay? Now, this is all 12 volts. Now, if I want to find my equivalent capacitance, oh gosh, what is that? I think it's a simple number. 1 over 6 plus 1 over 4 plus 1 over 12. That is 2 plus 3 plus 1. That's 1 over 6 over 12, which is 2 microfarads. So the equivalent of that is 2 microfarads, which means that if I have a 2 microfarad capacitor with a 12-volt battery, that means they all have what charge on them? 2 microfarad equivalent capacitance with a 12-volt battery. What's the charge on that capacitor? 24. That means that this has 24 microcoulombs. This has 24 microcoulombs, and this has 24 microcoulombs. Then I can figure out my voltage. Remember, voltage is Q divided by C, so that's going to be 4 volts, 6 volts, and 2 volts. Notice the biggest capacitor has the smallest voltage, and those 3 voltages, 4, 6, and 2, add up to equal to 12. Now, I can start putting some of these in. I have, this is going to be 6 volts here. I'll do it in red. 6 volts, 2 volts here. I'll have 1 volt and 1 volt there because I have 2 identical capacitors. And then I have 4 volts and 4 volts here. Now that capacitor, that circuit might be a little more difficult than what you'll see, but not much more difficult. The most difficult part about this is drawing that first step. Okay? If you get into it and the numbers are all wonky and it's just getting lots of decimals, you're not doing it right. Okay? You should get nice even numbers when you work through the problem. So that'll be a good sign to you if you're just completely off base. You understand what I'm saying? Because it should work out like this, where you get nice, even numbers. I think there's one question on the entire test where you'll really need to use your calculator. And even that, I think that you could probably estimate what the answer is. Okay? I'll post some of these along with their videos online just so you can get a feel for these. But only focus on these capacitor circuits because there's other stuff on there that the 200 level students do that you don't. It's sort of like what you're doing, but it's also different. Is that okay? I'm going to clear this. I do want to show you there's probably on this exam also a no, I'm sorry. There's no multi-loop circuits on this. I'm just going to post the capacitor circuits because the multi-loop, you have lots of those to practice. Okay? I like these. It's really just to help you with spatial thinking, that you can look at the diagram of a circuit and reorganize it in your mind or see that 2 different circuits are the same. And that's not really just a skill for physics. That's a skill for life, that you can think spatially. Okay. You want to look at another one of those? All right, let's see. $16 spring. Okay, here's a different one. So I have, oh, this one's good. I'm going to come off of this battery right here. I come up to here, and notice how many branches do I have in that first parallel circuit? In that first parallel branch, how many I got? 1, 2. I got 2. I got 2. I got 2. I got 3. Any more than 3? There are 3 independent branches in this. I got one right here. I got one right here, and I have one right here. All those are part of the same parallel branch within that circuit. I'll draw it in just a second. But then they all come back together over here. So if I were to draw this, it would have C1 right here, C2 and C3 right there, and then C4 right here. I'm just going to put the values. I have 3 microfarads, 3 and 6 microfarads, and then 6 microfarads. That I've drawn is this part of the circuit. And then it all closes down on itself. Now, I know that it looks like this is not one point, but because there aren't any capacitors along this part of the circuit, that means that I can redraw it as just I can close down all those wires to a single point. Then I have another parallel branch that's going to have just two branches or two parts to it. There's those two 4 microfarads, and then there's a 2 microfarad. 4, 4, and 2. And then it all comes back, all comes back to my 12-volt battery. Now, you should be able to see some of these. Hopefully you can see these patterns in your head. The 4 and the 4 is 2 microfarads. That means that that's going to be 4 microfarads, meaning this entire thing right here is 4 microfarads. And then I have, this becomes 2 microfarads. And then I have a 3, a 6, and a 2. 1 over 3 plus 1 over 6 plus 1 over 2. That's 2, 6 plus 1, 6 plus 3, 6. 2 plus 1 plus 3. That's 6, 6. That's 1. So I have, this is my near finished. Didn't I do that right? Yeah. I have a 1 microfarad and a 4 microfarad. And then you would follow the same procedure to find what are the voltages on all those capacitors and what are the charges on them. Okay? That's one of your free responses. That's 2 or 3 questions. I think I just asked 2 for that one. Very first question, number 1. Get it perfectly right. Then it just sets a good tone for the whole exam. Okay, that's a lot of capacitors. But more of that or more specific questions, what do you want to do? Tristan? Is that Tristan back there?
Yes.
Yeah.
When you did the left parallel electric so the triple one, you added them as 1 over the farads, right?
The 3 and the 6 in series?
3 and 6.
This one right here?
Yeah, I saw that, but then.
Oh yeah. Oh gosh. Yeah.
I used the resistor.
I'm sorry. Yeah, you were right. I used the resistor one. Well, there you go. Thanks. So it should be actually 3 plus 2 plus 6. That's 11 microfarads, right? And then the other one is 2 and 2. That's 4 microfarads. Yes, it would be 11 and 4. That seems kind of wonky. Why would I give them those numbers? Did I do that right? 3, 2, and 6. That's 11. Yeah, and then 2 and 2 is 4. Yeah, that's right. Okay, does that make sense now? Okay. Megan, were you going to ask the same?
No.
No.
I was going to ask, you're given the current in a multi-loop, like it gives you the magnitude. Can you assume the direction is correct?
Yes. Although in your exam, I didn't do that. In your exam, I gave you one of the other types where I just make it where it has a loop without a resistor. Either way does the same thing mathematically. It makes it where you only have to solve for a single variable. And that's what I did. But the answer is yes. That's on any of the old exams. If I give you the magnitude, then you can assume the direction is correct too. Okay? But if I don't give you the magnitude, you can't assume that. In fact, on your exam, don't assume that I drew the directions correctly. Can I get rid of this, y'all? Start the thing back. Yes, okay. What else? Yeah, of course. Let's see. You have a particular one in mind, or you may just pick one? They're pretty much all the same. I think have we done this? No, that one has. I'll pick a different one. That's more like what you have. Now, big plans for the weekend? Study. Y'all are lame though. Every single one of you. All of you are probably going to study, aren't you? What do you mean no choice? You have a choice.
We have a choice. it's just going to be a very
Okay, did we work this one today in class? I don't remember. I'm gonna do this one, then we can do a different one if you want. Okay, so here I have a circuit. I want to know all the currents. So we'll just say, I'm going to give you a diagram that's going to say I1 equals blank, and then it's going to be left or right. I'll write out left or right. So you'll get the magnitude, and then you'll circle, is it left or right? I won't have these arrows right here. That's something that you're going to have to figure. And then I also won't have, no, I think I do have I1, I2, I3. I just don't have the directions. So you'll have to pick a direction. So you want all three of them. So what you're going to have to do is write loop rules, and you're going to have to write 2 loop rules and 1 junction rule. I know I'm going to have to write a junction rule because in this circuit, I3 is not going to be in any of my loop rules. I know that because there's no resistor there. Okay? Circuit's going to look almost identical to this, just different numbers. So let's write the top loop, write the bottom loop. Actually, no, let's be more clever than that. Let's write this is a good question. Which loops are you going to write? To make this easiest, which loops would you write? Let's think about it for a second. I want to write loops that only have one variable in them. The bottom loop is one. What else? The big loop, and then I can write the junction rule. That's the easiest attack, is to write the bottom loop, the top loop, the bottom loop, the big loop, and then the junction rule. So think about it a little bit before you jump in. Let's do the bottom. I'm going to do it over here. The bottom, I'm going to start here and go in this direction. So that's positive 4 minus 3I2 minus 2 equals 0. Now I'm going to do the top loop. I'm going to start here and go in the same direction. Or not the top loop, the big loop, sorry. The big loop is 4 plus 10 minus 4I1 equals 0. And then I can write the junction rule. I'll just pick any junction. It's like I1 and I2 go into that junction, and I3 comes out of that junction. And then I solve those first 2 equations for I2 and I1. I2 is equal to negative 2 divided by 3, or 2/3 amps. I recommend that you just keep it in fractional form. But if you put it into decimal, that's fine. And then solve the next one for I1. I1 is negative 14 over negative 4. That's 7/2 amps. And then to find I3 is going to be the sum of those. It's going to be 7/2 plus 2/3. What's that? 14/6 plus 4/6, 18/6, 9/2, 9/3, whatever that is. So then I would report all of those, and then I1 would be to the left, I2 would be to the left, and I3 would be to the right. That's 3 questions on your free response. Easy, right? I could do that.
Can you go over again like how you make the left or right? Because that's how much I have.
Yeah. So the reason I know that it's left or right is because these are all positive. And when they're positive, I just report the direction as it's labeled. Now you're going to pick that direction. So whether or not you pick it correctly, they might be positive or negative. Not that you pick the direction wrong, it's just it's not the right direction. Okay? So if you don't get the direction right, that means you get half credit for that question, for that one of those 3 questions. Tristan?
So you're saying the number would be exactly the same, it would just be negative. So if you receive a negative number, just pick the opposite direction.
Exactly right. You'll always get the right magnitude if you've done it correctly. It's just sometimes it'll be positive, sometimes it'll be negative, depending on how you chose the direction.
But you go by the direction of the current to see the direction.
I'm sorry, repeat.
You go by the direction of the current that's already in the
Right. So if it's positive, like right here, I2 we found to be positive. We had chosen the direction of that to be to the left, and so it's to the left. If it were negative, we would say I2 was to the right, right? We would just take the opposite. And I said you'll have, so I1, what you'll do is if it's to the left, you just circle to the left. You give I1 as 7/2. I'll have a blank there for you, and you circle left or right. I don't want to be difficult. I just want everybody to get it right, okay? I know that a lot of you aren't going to get it right. No, that's not true. A lot of you will get it right. More than I think should get it wrong are going to get it wrong, because everybody should be getting it right. I'm telling you exactly what the question is. And so I want everybody to get this first page completely right. Honestly, like, it makes my life a lot easier if you just all get it perfectly right. It's a lot easier to grade. Can y'all do that for me, please? Like, please just everybody get it right. Or if you think you got it wrong, just don't write anything, and then that's easy to grade too. But don't do that, because if you write something that's right, you're more likely to get some credit. I mean, it has to be, you know, sort of right, at least. Don't just write a love note to your interest, but write something that's right. I forgot who asked that question, but does that help with the multi-loops? Practice them. There's a bunch in the old exam, so practice those. They're on every exam. Was it 17? That's correct, 17. Okay. All right. What else, y'all? Y'all okay in these combo circuits? Yeah. You want to do this one? This was a fine one. Erase all this junk here. My kids are going away tomorrow for the afternoon, evening for a church thing, so my wife and I get to be home without them. That's exciting. We're going to go out, like a date night, all that. Yeah, I don't care, do you? You're going to be studying, right. Okay, so here I want to know, the question is, what is the equivalent resistance? This will be like on your free response, by the way. Is that right? Yeah, you have a combo circuit. It's going to be about this difficulty, about this number of resistors, different numbers, maybe a slightly different layout, but something really similar. So on these, the first thing you want to do is look for the part that's only series or parallel. In this case, it's series. And I know that that's 3 ohms. And then I'm going to go ahead and jump ahead a little bit and recognize that this is a 333 in parallel. And I know what a 333 in parallel is. That's 1 ohm. 1 over a third plus a third plus a third. It's something I've seen before. So I'm going to go now draw that circuit where I have 3 ohms and 1 ohm. 12 volts. Now, I can go ahead and draw that next one, which is just the equivalent, which is 4 ohms. And that's the answer to this question, that the equivalent is 4 ohms. And I think I do ask you what's the equivalent resistance. But regardless, if I don't ask you, you still have to know it before you move forward. Tristan?
Okay, we look at calculating the amperage and voltage for each one.
I'm going to do everything. Yes, so let's do everything. So then I say I have 12 volts. And then I step back and I start thinking about what is the current. I know that this current, I, is V over R, right? 12 over 4. That's 3 amps. So I have 3 amps going through that resistor. That means that I also have 3 amps here and 3 amps here because, let's see, resistors in series have the same current, and they have the same current as their equivalent resistor. So if I have 3 amps here, I have 3 amps on those 2 resistors that make up that 4 ohm. And then I can say, well, if that's, come on, then I have 9 volts here and 3 volts here. Now, I probably could have just reasoned that out because I know that I have one voltage that's 3 times the other because of the relative sizes of the resistors, and also they have to add up to equal to 12. But nonetheless, it's 9 and 3. Now, I've answered everything about this resistor. It's 9 volts and 3 amps. Now I can also say that these right here are 3 volts and 3 volts right here, because they're going to have the same voltage as this resistor. Further, I know that this has 3 volts across those 2 resistors. So those 2 resistors split up 3 volts. Now, what voltage does the 1 ohm resistor have? 1 volt. It has 1 volt, and this has 2 volts. I skipped a little step there, but it's good if you can skip that step. Let me do it over here. I'll show you I have my 1 and my 2 ohm. And I know that across them they have 3 volts. The 1 and the 2 ohm are 3 ohms equivalent. And that 3 volts across 3 ohms gives me 1 amp of current. That means I have 1 amp here and 1 amp here. That means that the voltage is 1 times 1 or 1 volt, 1 times 2 or 2 volts. So that's how I did that. But over here, I just looked at them and said, well, I got 3 volts split across a 1 and a 2. It's kind of easy because 1 plus 2 is equal to 3. And then 1 and 2, and so that's okay. But if you don't see that, that's okay. What you need to do is to find the equivalent resistance, then find the current, and then apply that current to all the resistors that make up that equivalent resistance. Okay, that's problem number 2 on your free response. And plus, like if you can do that, you'll be good on a lot of the problems in the multiple choice, because there's a lot of circuits on the multiple choice part. If you've mastered this, I'm fairly confident that you will make a B or A on the test. Okay, what else? Megan.
Another multi-loop program that covers your Junction Rule.
Like where the directions of them are wrong? I can try, Megan, but it's hard because I don't know what they are. Like it was just sort of luck that I chose them this time. But let's see. Y'all good on these things? Remember we did one like this in class today? Huh? I know, but it was similar to it. Yeah. You okay on this? Okay. Megan, we'll get to your question. Can we do this one while I will do another multi-loop, but let's do this one. This one is like the one we did in class, but there are no numbers. You will have one like this, but a junction rule problem. So what I'm looking for is which equation is correct. So I just go through one by one. I2 plus I6 equals I5 plus I4. All right, I5 and I4 are right here and here. So I have I5 coming in, I2 coming in. The way this should read is I2 plus I5 equals I4. So that's not correct. I4 plus I6 equals I3. That's this junction right here. It should read I4 plus I3 equals I6. Not correct. I'm doing the incoming currents equal the outgoing currents. This next one is I2 plus I6 equals I1. Is that one correct? Not correct. I'm looking at this junction. My incoming currents are I1 and I6, and that would be equal to I2. Not correct. And then finally, I2 plus I5. Oh, look, that's the first one that I wrote. So that one is correct. All right, let's find, you're going to do electromotive force. Make sure you know how to do that. Oh, goodness. Let's go on to the website. We'll look at some older exams. Do a lot of your professors have online classes during the week? You know what I mean? Like everybody meets in class every day of the week? What classes don't? For example, biology. Yeah. Okay. Yeah, like our department, we've made a conscious decision to have everything in class. Not that we're not concerned about your safety, like we want you to be safe, and I think that we are. I think that university's been doing a really good job. Okay, did we do this one? Is this the same one we did previously? Let's see. I'm pretty sure one of these is incorrect. I can tell you. Okay, can we do number 24? We'll find the current through the 2 ohm resistor, and then we'll find the other currents too. But I'm going to choose directions. I think I'm choosing these incorrectly, but I'm not entirely sure. I'm going to call this I3. I will call this I1, and then I will call this I2. But again, I don't know if I'm choosing them incorrectly. It's sort of hard to tell. It's a combination of the size of the batteries and the size of the resistors and how the batteries are oriented with respect to one another. So I'm pretty sure I at least got one wrong. And I want to know what is I1, I2, and I3. So first of all, I'm going to look at it, I'm going to think, okay, which equations do I want to write? And if I look at this, I'm thinking, well, y'all think for a second. Looks like the right loop might be a pretty good loop, right? I can write the right loop, and then the what loop? The big loop, and then the junction rule. Those are good equations to write because they're going to give me equations with only one variable in them. So let's write the right loop first. I'm going to start right here and go in this direction. That's going to be 4 plus 3I1 minus 12 equals to 0. And then what did I say, the big loop? Right. The big loop is, that's the big. Let's do the right one right now. The right loop is, I'll start here and go in the same direction. That's minus 2I2 plus 6 minus 12 equals to 0. And then I'll just pick any junction. Looks like I got I2 coming in, and I1 and I3 are going out. Okay? So I1 and I2 are pretty simple. I just solve these equations. That is I1 equals 12 minus 4 is 8/3 amps. I2, I can solve here. I2 is negative 6 divided by 2, negative 3. Whew, I got one wrong. That's good. So I2, I'd said was down, but it's really up. And then I3 is going to be I2 minus I1, which is going to be minus 3. Notice I carry that negative. I always carry the negatives until the very end of the problem. Minus 8/3, which is, what's that, 9/3, or 9/3 plus 8/3 is negative 17/3 amps. So I1 is up, because I had chosen I1 to be up, and this is positive. I2 is also up, because I had chosen this to be down, but it came out negative. And then I3 is down, because I'd chosen it up, but it came out negative. Okay? That's pretty good. 2 for 3. You chose them correctly. 2 for 3. Does that help, Megan? Yeah. I'm not going to choose the directions for you. You have to choose those. Okay? What else? These are all good questions, Carson. Yeah. Which of these resistors right here is giving the most power in this circuit? We'll say this is 12 volts. It doesn't matter, but we'll say it's 12 volts. Which is giving the most power? R1 is, right. The reason I know that is because this is 6, 3, and 2 on this whole thing. It's 6, let's do 6 plus 3, 6. That's 1. This is all 1 ohm. So I'm going to have, let's call this 10 volts actually. I'm going to have 8 volts over here and 2 volts over here. That means that the one with the bigger voltage has the bigger power, because power is V squared over R. I know that's not exactly what you were asking, but that's a question like you could see on the exam regarding to power. Just remember that power is proportional to V squared for a given resistance. Okay, if V goes up, the power is going to go up. Let's look at another one, I think more like what you were asking. I like this one right here. So you'll have a simple one, I think, where I just want to know, I give you the power and or the voltage or the current, and I ask for some other thing. Remember, there are 3 equations regarding power. This is sort of the main one, but then there are also variations of that where we're subbing Ohm's law in to get just different relationships. So here I have V and P, and I want to know the resistance. So I would say P is equal to V squared over R. And I say 600 equals 120 squared divided by the resistance. I don't know what that is. It's pretty small, huh? It's 24 ohms? Yeah. Remember, too, that devices that put out a lot of energy have a low resistance, okay? Because something that puts out a lot of energy, like a heater or a hairdryer, those will need very high currents. They need to put a lot of electrons through the wire to carry a lot of energy, so they're going to have a really low resistance. And then things that have a low power will have a big resistance. Let's see what else we got. That's all the power ones on this. Is that okay? I forgot who asked that. Is that okay? Yeah.
So power and resistors are like proportion, like power goes up, resistance goes up.
No, power and resistance actually are indirectly proportional. So if resistance goes up, power goes down. Those equations are on your equation sheet, by the way. You'll have that, of course. It'll be on the back. Wait, no, where will it be? What did I do last time? Oh, I put it on your bubble form. I'll just take the equations you need and put them in that block on the bubble form. Okay? Anything else? Are y'all nervous about this exam? Yeah, nah, yeah, yeah. Even if you're not nervous, you should still practice a lot. All right, well, I'm going to stop this. If you have more questions, you can ask me. Make sure you see me. I didn't get any